Welcome everybody. My name is Saskia Maury and I'm a Pollution Support Advisor at the Joint Nature Conservation Committee, otherwise known as JNCC. This presentation will introduce the Joint Nature Conservation Committee, or JNCC, and the Reducing Pollution Through Partnership project. We will explain the aim of a local sense check and set out the method used based on information provided by the International Union for Conservation of Nature, known as IUCN. We will then present the pilot country results specific to Indonesia, where we welcome discussion based on how the results reflect your local knowledge. This video is the third out of a series of 3 videos created to support the delivery of the Reducing Pollution Through Partnership project. The first video introduced the methods using the global analysis, and the second video presented the results of the global analysis. This third video uses the results from the global analysis and focuses on Indonesia to detail the results specific to your country. JNCC is a public body that advises the UK government and devolved administrations on the United Kingdom and international nature conservation. Our people are dedicated to providing high quality scientific evidence and advice on the natural environment. The aim of this project is to scope and help design a wider pollution programme to be delivered by the United Kingdom in low and middle income countries. The programme is to enhance the ability of these countries to manage and to reduce air, chemical and waste pollution. Our priority is to engage with pilot countries to understand how better deliver a fit-for-purpose pollution programme in the future. JNCC was commissioned by the United Kingdom Department for Environment, Food and Rural Affairs, known as DEFRA, to deliver the project scoping year. The aim of the local sense check is to validate the preliminary results of the global analysis and determine whether this reflects local knowledge in Indonesia. We are looking to find out whether the results are a true representation of how pollution impacts threatened species in your country, and your help is valuable in achieving this. As the basis for this analysis, we use the data from the International Union for the Conservation of Nature, IUCN, Red List of Threatened Species. This is a list of species assessed for extinction risk using the IUCN Red List categories and a set of criteria. Threatened species are those with an assessed extinction risk as either critically endangered, endangered or vulnerable, and these species have been included in this analysis. We have also included those listed as near threatened, and these are species who are close to the threatened thresholds or those that would be threatened without ongoing conservation measures. The data can be used to determine what is impacting which species globally. The information is publicly available on the IUCN webpage, and the databases are available at request. This IUCN Red List assessment also includes the major threats to species, such as the different forms of pollution listed on this slide, as listed under the Category 9 of the IUCN Red List Threatened Categorisation Scheme. And this assessment is what formed the basis of the analysis. A more detailed explanation of the methods and criteria used can be found in the Pilot Country Pollution Analysis Report for Indonesia. From the global analysis, we are able to uncover the percentage of species impacted by pollution in Indonesia, given as a proportion of the total number of threatened species. The pie chart shows that 22% of species are threatened by pollution in Indonesia, with 78% of species impacted by other threats. Other threats, as classified by the IUCN Red List assessment, may include threats such as energy production and mining, biological resource use, geological events, and agriculture and aquaculture. We are interested to hear how these proportions shown relate to what you know about pollution in Indonesia. The global analysis also enables us to identify the percentage of species threatened by pollution that are also impacted by climate change. Of the species threatened by pollution in Indonesia, 61% are also impacted by climate change. This is compared to 39% of species being threatened by pollution but not climate change. As before, we're interested to hear how these proportions shown relate to what you know about pollution in Indonesia. In this table, you see the number of species impacted by pollution in Indonesia. This table groups the number of species into the higher pollution threat categories, but a more detailed results table of the pollution threat breakdown is available in the Pilot Country Pollution Analysis Report for Indonesia. At the top of the table, there are 549 species impacted by agricultural and forestry effluents, which includes the subcategories of nutrient loads, soil erosion, sedimentation, herbicides and pesticides, and unknown, unrecorded. The unknown, unrecorded category is for cases where the pollution is not specifically captured under the classification scheme, or where the source of the pollution may be unknown or from a historical source. Next down the table, and the pollution threat with the second highest number of species impacted, is domestic and urban wastewater, impacting 450 species. This includes the subcategories of sewage, runoff, and unknown, unrecorded. At the bottom of the table, we find excess energy impacting 5 species. Excess energy includes the subcategories of noise pollution, light pollution, thermal pollution, unknown, unrecorded. We would like your feedback on whether there is any important information missing to help us understand the sources, types, locations, and impacts of pollutants in your country. Overlaying range maps of any species which is assessed as threatened by pollution can hotspot where multiple species are impacted. All entries only include ranges of species known to occur in an area. This gives us a global picture of the extent of species assessed as threatened by pollution, but we can zoom in on specific countries and explore the breakdown of species and their threats. We are looking to find out whether the information shown on the following pollution heat maps about the distribution of species threatened by each pollution threat type reflects your understanding and experience. It is worth noting that all heat maps and more detailed information about the species can be found in the Pilot Country Pollution Analysis Report for Indonesia. 450 species are impacted by the higher category of domestic and urban wastewater in Indonesia, which is made up of the subcategories of sewage and runoff, which I'll present in the following 2 slides. This heat map shows the overlapping ranges for species where range data is available. Please see video 1 for reasons data may not be available for all species. The darker areas are where multiple species are impacted. Domestic and urban wastewater is defined by the IUCN Red List as waterborne sewage and non-point runoff from housing and urban areas that include nutrients, toxic chemicals, and/or sediments. Hotspotting is predominantly focused around the coast and offshore, with a darker region between the islands of Sumatra and Borneo. There is also a hotspot following the Kapuas River in Borneo, as well as a hotspot surrounding the city of Jakarta. Of the islands, we can see that Sumatra has the greatest hotspotting internally. Sewage is a subcategory of domestic and urban wastewater, affecting 84 species, and this heat map shows the overlapping ranges for those species impacted by sewage in Indonesia, where range data is available. The darker areas are where multiple species are impacted. Examples of sewage as defined by the IUCN Red List assessment include discharge from municipal waste treatment plants, leaking septic systems, untreated sewage and outhouses. There is great hotspotting between the islands of Sumatra and Borneo. There is also a hotspot in central Kalimantan and following the Mahakam River from the city of Samarinda in Borneo, as well as surrounding the city of Jakarta. The table shows that fish are the class with the most species impacted, with 51 species. This is then followed by crustaceans with 16 species and sharks and rays with 7 species impacted. At the bottom of the table are reptiles with 4 species found to be impacted by sewage. Runoff is another subcategory of domestic and urban wastewater, affecting 21 species, and this heat map shows the overlapping ranges for species where range data is available, impacted by runoff in Indonesia. The darker areas are where multiple species are impacted. Examples of runoff as defined by the IUCN Red List assessment include oil or sediment from roads, fertilizers and pesticides from lawns and golf courses, and road salt. There is hotspotting predominantly along the coastline, and as before, there is a darker hotspot between the islands of Sumatra and Borneo. There is also a hotspot following the Mahakam River from the city of Samarinda in Borneo. The table shows that fish are the class most impacted by runoff, with 15 species affected, and this is followed by sharks and rays with 3 species, and then reptiles with 2 species impacted. At the bottom of the table are mammals with 1 species impacted by runoff. There are 426 species impacted by the higher category of industrial and military effluents in Indonesia, which is made up of the subcategories of oil spills and seepage from mining. This heat map shows overlapping ranges for species, where range data is available. The darker areas are where multiple species are impacted. Industrial and military effluents are defined by the IUCN Red List as waterborne pollutants from industrial and military sources, including mining, energy production, and other resource extraction industries that include nutrients, toxic chemicals, and/or sediments. There is widespread hotspotting across Indonesia, with darker areas along the coastline and offshore. Of all the islands, Sumatra is the most hotspotting. However, there is also a hotspot surrounding the city of Jakarta in Java, as well as hotspotting in central and west Kalimantan in Borneo. Oil spills are a subcategory of industrial and military effluents affecting 7 species, and this heat map shows the overlapping ranges for those species impacted by oil spills in Indonesia, where range data is available. The darker areas are where multiple species are impacted. Examples of sources of oil spills as defined by the IUCN Red List assessment include leakage from fuel tanks, oil spills from pipelines, PCBs in river sediments, etc. Hotspotting is predominantly focused on the coastline, suggesting oil spills impact more coastal and/or marine species. In Borneo, we can see a hotspot east of the city of Banjarbaru, where there is a large river network, and along the Kapuas River east of the city of Pontianak. The table shows that mammals are the class most heavily impacted by oil spills, with 3 species, and this is followed by reptiles with 2 species impacted. At the bottom of the table are fish and sharks and rays, both with 1 species impacted. Seepage from mining is a subcategory of industrial and military effluents affecting 57 species, and this heat map shows overlapping ranges for species with available range data impacted by seepage from mining in Indonesia, with the darker areas being where multiple species are impacted. Examples of sources of seepage from mining, as defined by the IUCN Red List assessment, includes mining tailings and arsenic from gold mining. Hotspotting is predominantly focused on the eastern edge of the island of Sumatra, stretching across the island of Borneo. Within Borneo, we can see darker hotspotting surrounding the city of Pontianak near the Kapuas River, as well as towards the south of the island near the city of Banjarbaru. The table shows that fish are the class most heavily impacted with 45 species, and this is followed by crustaceans with 4 species, and then sharks and rays with 3 species impacted. Reptiles and amphibians are at the bottom of the table, with 1 species in each category impacted by seepage from mining. "549 species are impacted by agricultural and forestry effluents in Indonesia. The heat map shows overlapping ranges for those species where range data is available, impacted by a higher category of agricultural and forestry effluents, which is made up of the subcategories of nutrient loads, soil erosion, sedimentation, and herbicides and pesticides. The darker areas are where multiple species are impacted. Agricultural and forestry effluents, as defined by the IUCN Red List, as waterborne pollutants from agricultural, silvicultural, and aquacultural systems that include nutrients, toxic chemicals, and/or sediments, including the effects of these pollutants on the site where they are applied. There is widespread hotspotting, predominantly surrounding the coast and offshore, which may suggest this pollution threat impacts more coastal and/or marine species. There is also darker hotspotting on land towards the east of the island of Sumatra. Nutrient loads is a subcategory of agricultural and forestry effluents, affecting 75 species, and this heat map shows the overlapping ranges for those species impacted by nutrient loads in Indonesia, where range data is available. The darker areas are where multiple species are impacted. Examples of nutrient loads, as defined by the IUCN Red List assessment, include nutrient loading from fertilizer runoff, manure from feedlots, and nutrients from aquaculture. There is predominantly hotspotting between the islands of Sumatra and Borneo, as well as south of Papua. There is also hotspotting near the cities of Jakarta, Samarinda, and Banjarbaru. The table indicates that fish are the class most heavily impacted, with 33 species impacted by nutrient loads, and this is followed closely by snails and slugs with 32 species impacted. At the bottom of the table are reptiles with 2 species impacted. Soil erosion, sedimentation is a subcategory of agricultural and forestry effluents and impacts 461 species. This heat map shows the overlapping ranges for species with available range data impacted by soil erosion and sedimentation in Indonesia. There is widespread hotspotting with darker areas focused between the islands of Sumatra and Borneo, as well as south of Papua. Within Sumatra, hotspotting is predominantly in the east of the island. In Borneo, there is a hotspot near the city of Pontianak, as well as the city of Samarinda, following the Mahakam River. The table indicates that sea anemones and corals are the class most heavily impacted, with 339 species. This is followed by fish with 90 species impacted. At the bottom of the table, we find birds and insects, both with 1 species impacted. Another subcategory of agricultural forestry effluents is herbicides and pesticides, affecting 62 species, and this heat map shows the overlapping ranges for species with available range data impacted by herbicides and pesticides in Indonesia. The darker areas are where multiple species are impacted. Examples of herbicides and pesticides as defined by the IUCN Red List assessment include herbicide runoff from orchards. Hotspotting is mostly focused inland, with the islands of Sumatra and Borneo being noticeably darker. There's also hotspotting near the city of Jakarta. Of all the islands, Papua is considerably lighter than the rest. The table shows that fish are the class most heavily impacted, with 31 species, and this is followed by mammals with 9 species impacted. Crustaceans and insects are at the bottom of the table, both with 1 species impacted. 11 species are affected by garbage and solid waste. This heat map shows the overlapping ranges for species with available range data impacted by the higher category of garbage and solid waste in Indonesia. The dark areas are where multiple species are impacted. Garbage and solid waste is defined by the IUCN Red List as rubbish and other solid materials, including those that entangle wildlife. The heat map shows hotspotting around the coastline and offshore, suggesting that it is mainly coastal and/or marine species threatened by garbage and solid waste. There is also hotspotting on land in the east of Sumatra and in Borneo. The table shows that reptiles are the class most heavily impacted, with 5 species, and this is closely followed by mammals with 4 species impacted. The crustaceans and fish both have 1 species impacted in each class. Airborne pollutants affect 343 species. This heat map shows the overlapping ranges for species where range data is available, impacted by the higher category of airborne pollutants in Indonesia. The darker areas are where multiple species are impacted. Airborne pollutants are defined by the IUCN Red List as atmospheric pollutants from point and non-point sources. Airborne pollutants include subcategories of acid rain, smog, and ozone. There is hotspotting predominantly offshore, as well as being lightly focused in Sumatra. This is supported by the table which shows that sea anemones and corals are the class most heavily impacted by airborne pollutants, with 339 species impacted. Mammals are at the bottom of the table, with 1 species impacted. In some of the cases, particularly large ranging species, it is hard to associate the threats throughout the species range, and it's not entirely clear where the species are located. So if we wanted to increase the chances that the species range is representative of threats such as pollution, we can limit our selection of species to only those that have small ranges. So here we demonstrate using the IUCN definition of restricted range, which is species whose entire area of occupancy is up to a maximum of 2,000 kilometers squared. All these areas are so small that the species would be likely to be endemic to a single country. The orange patches shown on the map are the distribution of restricted range species currently in decline in Indonesia due to pollution. Because the threats to restricted range species are so site-specific, tackling pollution in any of these targeted areas is likely to reverse the risk of extinction for at least 1 species. The table shows that there are 128 restricted range species in Indonesia. The fish are the class in Indonesia with the most restricted range species impacted by pollution, with 58 species. This is followed by snails and slugs with 32 species and crustaceans with 21 species. Reptiles and mammals are at the bottom of the table with 1 restricted range species in each class impacted by pollution. The global analysis allows us to explore the species threatened by pollution by taxonomic group. The graph on the left shows the number of species threatened by pollution divided by class. This graph reveals sea anemones and corals as having the greatest number of species threatened by pollution. This is then followed by bony fish and snails and slugs. Insects are shown to have the least number of species threatened by pollution. The graph on the right highlights the proportion of species threatened by pollution in Indonesia, divided up by class. Similarly, this graph shows the sea anemones and corals are the class with the greatest proportion of species threatened by pollution, followed by bony fish and snails and slugs, with insects having the lowest proportion of species threatened by pollution. Classes not shown are where there are no species meeting the criteria of being threatened or near threatened as classified by the IUCN Red List, or do not have at least one of the IUCN pollution threat categories increasing their risk of extinction. The global analysis also enables us to pick out specific species threatened by pollution. And this slide highlights a few examples of species in Indonesia. All species on this slide have an extinction risk assessed as either endangered or critically endangered. From the top left to right, we have the critically endangered yellow-crested cockatoo, the endangered narrow-tailed stingray, and the critically endangered green sawfish. On the second row, we find the critically endangered Malaysian giant turtle, the endangered Nemitz tarsier, and the endangered bearded Paphiopedilum. It is possible to find more information about specific species on the IUCN Red List webpage and identify specific pollution threats impacting species. For example, searching the IUCN Red List website for the green sawfish reveals that this species has an extinction risk of critically endangered, here shown in bold red. The information also shows that this species is threatened by agricultural and forestry effluents, and in particular, nutrient loads and soil erosion sedimentation. This results in ecosystem stresses, and more specifically, ecosystem degradation. To summarise, results were obtained by overlaying range maps of threatened species by pollution and creating heat maps to hotspot areas where multiple species are threatened. The results can be broken down and shown by pollution type, species, and taxonomic group, with more detailed information being provided on the IUCN Red List webpage. Finally, we would like you to think about how this information reflects what you know about pollution in Indonesia. The next two slides present a series of questions we would like you to discuss, and we invite the workshop organiser to pause on each slide to allow you to think about the topics presented. Finally, we thank you for taking the time to listen to this presentation and value your help and discussions. We are also happy to answer any questions, and our contact details can be found on the last slide of this presentation.